Okay, the first question. So we saw that the Pythagoreans had this mysticism about geometric shapes. For example, they talk about an honorable person being upright, or a person who cheats is crooked. Are there any other geometrical images in our speech that have ethical connotations? So I wouldn't say that we share the same mysticism as the Pythagoreans, but there's definitely geometric images in our speech that have ethical connotations. So for a lot of you picked up, for example, square, or talking about someone as straight, obtuse, acute. These aren't, you know, like what the Pythagoreans do, but there is definitely a little bit of geometric imagery. And this goes back even to words like normal and so forth. Anyway. Okay, here's the second question about the quadrature of the lunes. So we had a trapezoid, and we put it in a circle, and then we put in some lunes, and we want to show that the area of the lunes equals the area of the trapezoid. So the first problem we had to do was actually construct the trapezoid, and this is fairly straightforward. So first you construct a length of square root of 3, and then you mark off points so that when you, and then raise a perpendicular. And so the idea is that you wanted the sides BA, AC, and CD to be 1 by construction. And you can do this because you're just working with quadratic lengths. And so it's fairly straightforward to construct the trapezoid. The next thing you had to do was to put a circle, show that you could put a circle going through all 4 points. So the way that we can do this is just choose 3 of the points, let's say A, B, and C, and we can put a circle through that. And so then the question is, well, does it have to go through D? And there's a couple of ways you could do this. The hint was to use Euclid 3, proposition 22. Since it's a isosceles trapezoid, we have that opposite angles add up to 180 degrees. And if it didn't pass through D, say it passed through some other point, D double prime, well, you've got a quadrilateral by Euclid 322. That angle B, D double prime C must also be X, because opposite angles have to add up to 180 degrees. But if D double prime was closer to B, then the angle would be greater. If it was further away from D, the angle would be less. So therefore D double prime actually has to equal D. And so then the basic idea then is, well, the area of the lune is this shape 1 plus 2 plus 3 plus 5. The area of the trapezoid is 4 plus 5. So basically what you have to do is prove that the 3 small lunes add up to the bigger lune. And this is true by Euclid 12.2, because we know the 3 arcs AB, AC, and CD are all equal, and the arc BD is square root of 3 times bigger, because 12.2 says that the circles are to the square of their diameters. And so since we've got similar figures here, since the chords, since they're similar, they must be also similar to the diameter. And so since BD is square root of 3 times bigger, that means that arc segment must be 3 times bigger than the segment for AB. And so that gives us our desired result. Okay, question 3 was referring to the Archimedes construction of the heptagon. First bit was straightforward. We have various ways you can do this. I did it by looking at the this right angle here. So we know that this right angle here, so we know that CV squared plus CA squared equals VA squared. CV is, so let's say it's a unit circle, that's 1. CA squared, or CA is half the radius, so that's square it, that's a quarter, that's going to equal then VA squared, what we want to find. So VA is square root of 5 on 2. And then for the second bit, we've got, we know that BA times BK equals ZA squared, and we know that BK is less than BA. Okay, so we have two things equal a square. We have a smaller thing is less than the side of the square is less than the bigger side of the rectangle. So that gives us BK less than ZA less than BA. And similarly, we can do it with the other equality. We get KA less than KB less than KZ. So putting those three things together, we see that ZA is the longest leg of the possible triangle. And from 1, we see that ZA is less than BA, but BA is BK plus KA. So we can say it can form a triangle.